We have commercial geocommunication spacecraft programs here at Orbital. Our program is different yet again from the commercial programs. You might think commercial and commercial, well, these things must be alike. Well, they're not. Some of these commercial customers that we work with are incredibly risk averse. I would argue they are more risk averse than the folks at JSC at times. And you might find that ironic because manned space versus commercial. Commercial programs have huge amounts of capital and future revenue streams wrapped up in their vehicles. And they direct us and they make us do things that seem very restrictive at times. On the COTS program, I would say as the chief engineer, I had a lot of latitude to work with my team to craft solutions that made sense as opposed to crafting solutions that were simply towing the line to a set of instructions that we were given. As a functional director, yes, I interacted with a lot of the processes and procedures here on the campus, and I also was involved in creating many of the processes and procedures over that 9-year period. And I would say that for the most part, you can find an equivalent process or procedure here at Orbital ATK that is essentially meets the same criteria or objectives as a process or procedure that was created at JSC. In a number of instances, we simply tailored a procedure for our program and then showed it and explained it to our counterparts at Houston, and then struck an agreement that we would adopt our procedure as opposed to, or process, as opposed to simply adopting the JSC procedure or process. That was successful in a number of instances. One in particular is fracture control. Now, for the COTS program here on campus, in terms of using processes and procedures that existed on the campus and applying them to the COTS program, I would say, by and large, we applied just about everything. We didn't have to create a large body of unique processes and procedures in order to execute this program. Cargo loading and how it impacts the Cygnus design and the Cygnus architecture, it really didn't significantly impact the Cygnus design. There were one or two key things that were strong considerations. In particular, for cargo operations, Cygnus has to turn from vertical to horizontal after fueling, and then it has to move around and be attached to the launch vehicle, and then the launch vehicle rolls and goes vertical again. So there's a lot of opportunities to slosh propellants around inside Cygnus after it's fueled. And so that final stage of cargo loading, known as late and final load, after Cygnus is fueled, there are some considerations there for how the Cygnus moves around relative to the requirements that we actually flowed to the propellant tanks to accommodate those requirements. So there's a little bit of a dance there in order to make those things mutually compatible. Another interaction that's, I would say, is a departure from typical spacecraft design is we are able to accommodate powered payloads on Cygnus in the pressurized volume. In order to do that, we also had to include special power supplies in the design of the Cygnus architecture. Those payloads weren't able to just plug straight into the Cygnus power buses. So those power payloads are present. We need to operate them in sequence with integrating a powered payload. And then we have the unique circumstance of, I would say, an extended period of time where Cygnus stays powered prior to the launch, the actual day of launch. So that's a couple of unique things, but they're not dramatic departures from how we do other spacecraft processing.